So here's an example of what's called an iterated integral. That means there are two integrals. And just so you understand the order, there's two things that will tell you the order. One is our limits of integration with respect to x are functions of y, and we know to do x first because it's the order, right? This, since dx precedes dy, we want to do dx first. So we want to integrate this function with respect to x. Integrating 1, of course, we just get x. Integrating 2x squared, we get 2x cubed over 3. Integrating this, keep in mind, relative to x, this is just a constant, so it's 2 times x times y squared. And so we have limits of integration, y for the lower limit, 2y for the upper, so we're going to put those numbers in what I just told you. So the x from here, we'll replace that with 2y, here it is. The 2x cubed over 3, we'll replace that with 2 times 2y cubed over 3. The 2xy squared, there's 2x, but x is 2y times y squared. And then minus, replacing y with all those. Well, the first one was x, so replace that with y. The next one is 2x cubed over 3, so we're going to replace that with 2y cubed over 3. And the next one is 2xy squared, so that's going to be 2 times y squared. And now I need to simplify this mess and then integrate. This is the iteration. See, we do one more integral and replace our y's when we're done that with upper limit 1, lower limit 0. This is just, from here on, this is a problem we would have done maybe in Calculus 1, definitely in Calculus 2. So we just need to simplify this awful mess here. And I don't even know if that's not a simplified version of it here, so let's see if we can't do that somehow. I got 4y cubed here, and this is like 16/3 y cubed here. 4 is how many thirds? 4 would be 12/3, and 16/3, that's 28/3, but here we're going to say minus 2/3, and then plus this 6/3, so 28/3 minus 8/3, that would give us 20/3 y cubed. There's the y cubed term. Let's see what about a y term. We got 2y minus y. Well, that's it. That's just one y. So we integrate y plus 20/3 y cubed between 0 and 1. And of course, integrating y with respect to y, see the dy? So it's with respect to y, we got y squared over 2. We got, raise this to 4, divide by 4. That would be 20 over 12. That would be 5/3 when I divide both by 4. So we got y squared over 2 plus 5y to the 4th over 3, evaluated between 0 and 1. When we put in 1, we get a half plus 5/3. When we put in 0, we got 0 here and 0 there. Here a 0, there a 0. So we wind up with a whole result is 13/6.
Unbelievable!
Yes, that's what it is, 13/6.